Okay, so the first is look at the permutation problems. Okay, permutation will play when you arrange something, putting into order, right? Suppose I'm giving you three different objects, say A, B, and C.
Mhm.
So I'm asking you, hey, could you choose two of these? Choose two of these objects at a time and putting into order. So in how many different ways you could arrange? When we talk about the order arrangements, then you have to use the permutation, right? The permutation means you are putting in order. So that means you are choosing two objects from these three at a time, right? Suppose if you choose A and B, what are the different arrangement I could make? I could put first A, then B, or you could make first B, then A, right? So I'm using now, I'm considering the order, right? Order is important here. If you check the first arrangement, the order is A and B. For the second one, B and A. These are the two different arrangements if you pick only A and B. But you are free to choose any of these, any of these two, right, from three. So some of you may choose, B and C. So if you choose B and C, how can I put that into order? Well, that is BC and CB, right?
Yeah.
Or you could choose A and C as well. If you choose A and C, then your orders will be A, C, and C, A. So these are the all possible arrangement I could make from the given three objects, and you are choosing two. Do you understand that point? Yes. Now in total, how many arrangement I have here? How many different arrangement I have listed here? Count one by one.
Mm,
One, two,
6.
1, 2, 3, 4, 5, 6. So we have six different arrangements. Am I right? Therefore, if you are asked to, find the number of arrangements when you consider, the order is important, then use the permutation formula. So you are given, the formula says that the number of arrangements is given by NPR, right? In this case, the given number of objects is 3, therefore my N is 3. And you are choosing 2 at a time, therefore your R is 2 here. Therefore, the total number of ways or arrangement you could make is simply, what is NPR? That means N is now 3, P, R is 2. That's it. So this much number of ways you will make. So if you type this into calculator, you have to get 6, right? Because there are 6 arrangements. Does that make sense?
Yeah.
Yes. But if you talk about the combinations, now things are different. So
Mm,
under the combinations, you don't consider about the order. You are looking for different people in the group, right? Again, I'm giving the same objects A, B, C. I'm asking you to choose now two of these three objects, right? Now I'm asking, hey, how many different number of groups you could make? That means here we don't care about the order. You need to have, in each group should have, different combinations. So in this case, you are free to choose any of these three. Suppose if I choose A and B, that means my group is now AB. So you don't need to think about B and A because same group, right? If you, even though you flip the names, still you will have the same, people in the group. So if it is combinations, you don't think about the order, only different groups. So this is one of these, or I could choose A and C, or I could choose C and B. These are the only three possible groups I could make. That sounds good? How many groups? Three groups.
mhm.
That makes sense? So I'm not considering about the order. If I consider order, I would have put BA. BA and AB are same in group wise, right? Therefore, if you are asked to make some groups without talking about the arrangement, then use NCR. Combinations. Combinations means you could think of like groups. Okay? So in this case, how many? The given objects was 3. So you are choosing 2 at a time. So how many ways you could make the group? You could make in 3, choose 2 ways. So if you type this into your calculator, it will give you 3. Yes, because I made 3 different groups. Lisa, does that make sense now? The first one should be super easy, I believe. So we are given one contingency table, the different make of the cars model. The corresponding frequency values are given here. Now there are 100 in total. So if you find the total, it should be 100. So if you find the total, it should be 100. Okay. So we go there and randomly pick one car. We don't know which model it is. So now question is, what is the chance of having the chosen one is a Ford? So that means that's very simple. So there are how many Fords available here? There are 23 Fords out of 100, right? So you have to put always the denominator will be the total and the numerator will be the one you are looking for. So I need to have 23 out of 100. So if you simplify, that is 0.23, right? So what is the probability of the chosen one is not Toyota?
75.
Okay, how did you get that number?
You add everything that is not Toyota, and then that equals 75, and 75 over 100 is 0.75.
Okay, very good. 0.75. The question is finding the probability of not Toyota, right? If you assume this is your event E, then I could go for the the complement of E formula. Remember this formula? We learned P of E is equals to 1 minus P of E bar. E bar is the complement of the given event, right? So suppose if your event E is not Toyota, then what is your event E bar? So the complement of E is the negation of E. The E says that not Toyota. The negation of not Toyota is going to be Toyota. So E bar is Toyota. That means if you replace E bar by the Toyota, that means the probability of not Toyota is equals to 1 minus the probability of having Toyota, right? Under the Toyota, if you see 25, right? So the probability of choosing Toyota is 25 over 100. Then when you subtract that, that should be 0.75. This is another way to find, you see. Good. The next one, you see now you have two events. Remember, we are choosing only one brand. Is that possible to have both of them at the same time? Remember, you are choosing only one model car. It is impossible, right?
Yeah.
Therefore, these two events are mutually exclusive. Therefore, the probability of crystal or GMC, so you could think of these two as two events, A and B. Since these two are mutually exclusive, cannot happen at the same time, the probability of A or B is simply P of A plus P of B. Okay, addition rule number 1. Now, what is A here? A is choosing the Chrysler brand, right? The Chrysler brand, how many are there? 17 out of 100. Then B, even B is choosing GMC. How many GMC? So in total, going to be 35 over 100. Right. That is 0.35. That makes sense? So the last one, choosing Rolls Royce.
It's 0 because there's no Rolls Royce on the.
Exactly. That means this event is impossible event because there's no way to choose Rolls Royce because it is not there, right?
Yeah.
Therefore, this is impossible event. The probability of impossible event is always 0. Okay. What? When you see the word given, that's about what type of probability?
Given that he, she.
Yeah, if you see given word in your problem, that is going to be the conditional probability, right? That means, remember, you could check your notes. We have the conditional probability formula. The probability of any event B given condition event on A, that is given by the probability of A and B, this divide by the probability of A. You could check your note under the conditional, the probability. use this formula to do all the conditional problem. Okay, read the question carefully and write down everything in terms of symbolic way. So could you read the problem from the beginning, and I'm going to write everything in symbolic way. In a class of 100 students, 75 take statistics, 21 take calculus, and 13 take both subjects. If one student is chosen at random, the first part is find the probability of what? Find the probability that the statistics, right? So I'm writing in wrong way. So the student,
Stats, then calculus.
yeah, student takes statistics, given that he or she take cal, right? So this is, they're asking us to find out the conditional probability. So simply use the conditional probability formula I have written here. Okay, so if you compare your problem with the given one, your event B is now taking the statistics course, event A is taking calculus course, right? So we are asked to find now simply, if you think of this as your event B according to your notation here, this is your event A. That means if you change A and B here, how do you write in terms of statistics and calculus? Your event A says that taking calculus, and I'm using this formula, and the event B is now choosing statistics subject. So that means the probability of statistics given the calculus is simply probability of calculus and statistics over the probability of what?
A.
A. What is A here?
Calculus.
Calculus. That's it. Now what is your task? Your task is to find these two probabilities, this one and this one separately. Okay. Now tell me, what is the probability of having the chosen student studying both Cal and Stat? How many students are there, such as students? If you read the problem carefully, how many of them are taking both?
96.
13.
How many taking both? 13.
Yes, 13. So 13 take both out of how many total students?
100.
100. Therefore, the probability of having calculus and statistics taking both subjects is 13 out of 100. Okay, so this answer is only for the first probability. Remember, you have to find out two probabilities. Now this all over the probability of calculus. Now go and check how many students are studying calculus subjects.
21.
21. Again, out of
100.
100, because you are choosing one student from 100. Therefore, the total is always going to be 100. That's it. Now simplify this fraction. If you want, you could use the calculator and type. So the easy simplification, this 100 will go away, right? And you will get 13 over 21. So if you want to, you could round up this into 3 decimal places if you want.
4 something.
So what's the answer actually? 0.619. Do you understand now?
Yeah. So
when you see the given in your probability statement question, that means that is conditional probability. Use this conditional probability formula. Find the probability that the students are, that is in another way, right? They are asking us to find the probability of calculus given statistics. Okay, again you could think of this is event B and this is event A. Now if you look at the formula A and B, so that means stats and calculus, then these all divide by what?
100.
In probability?
Probability statistics.
Probability of A, right? A is statistics, yes. Okay. Now again find one by one. The numerator is the probability of stat and cal, like earlier, 13, no change, over 100. But now this guy is going to change. The probability of statistics, how many students are taking statistics?
75 over 100.
100, that's it. Now simplify this fraction, 100 will go away. So you will get 13 over 75. So that should be, okay. So these all, these two not hard, and let's see the third one. Now see, find the probability that the students take or statistics or calculus. Okay, this is the catch now. The probability of stats or cal. Okay, now you could think of this is event A and this is my event B. That means which formula now you have to use. You see the word here or?
Yeah.
So remember, if you look at your note, this is called addition rule. There are two addition rules there, right? Look at your note. The first rule for A or B is mutually exclusive. Ask yourself, you are choosing one student. Is that possible for that student to studying both of them at the same time?
Yes.
Yes, it is possible. Therefore, these two events are not mutually exclusive. Therefore, you have to use the second addition rule. Rule number 2 for not mutually exclusive event A or B. So if you look at your note, the addition rule number 2 says the probability of A or B when A and B are not mutually exclusive can happen at the same time. That is given by the probability of event A plus the probability of event B. Then what do you want to do? Then you have to subtract the probability of A and B. So please check your note. This is called the addition number rule, number 2. Okay? So use this formula. What is my event A here? Event A is choosing statistics, right? So this is the probability of stat. The next one, probability of cal. Then subtract the probability of stat and cal. You understand now?
Yeah.
Okay, now it is very easy. You know how to find these three probabilities. How many statistics students? 75 out of 100.
100.
What is the probability of calculus?
21 over 100.
Then subtract the overlap.
13 over 100.
Exactly. You see now? So if you simplify, how much it is?
83 over 100.
Yeah, 83 over 100. So that is 0.83. Does that make sense now?
Yeah.
Why did I use rule number 2? This is
Oh.
addition rule number 2 formula. Okay. Rule number 1 I have used here, right? This is rule number 2. Rule number 1 where?
That one. Oh.
Or at the previous one. Somewhere here I used. Yeah. This is rule number 1, right? Rule number 1 is here. In rule number 1 you have only 2 terms because of mutually exclusive. But here you have 3 probabilities because of not mutually exclusive. Okay?
Okay.
Yeah. So that is there. So now we have the last part D. What's the probability that the randomly selected student takes neither statistics nor calculus? The question is the probability of neither stats nor cal. So you could think of this all, you could think of like event E. Okay. Now I'm going to use the complement techniques, right? Remember the probability of E is given by 1 minus probability of E bar. Okay. What is E bar here? E bar is simply the complement of event of E. My event E says that choosing, the students neither stat nor cal. Now tell me, what is the negation complement of neither? You see, you have a hint here. What are they telling? The complement event of neither is going to be what?
E bar.
Or. That means if your E is neither, your E bar is going to be or. That makes sense?
Oh.
Therefore, if your event E is neither stat nor cal, your event E bar is going to be stat or cal. That makes sense?
So basically like the opposite of
Exactly. The negation of the statement E is going to be E bar, right?
Is that true for all situations?
All situations. True for any event. Okay? So now that means this formula is true always, right? Remember I gave you this under the complement event. So you could write down somewhere else. This formula is valid for any event E. P of E is always going to be 1 minus P of E bar. Remember my question part is here. The question part is finding P of E, right? But I'm going to use now P of E that is equivalent to 1 minus P of E bar, right? That means the probability of finding neither stat nor cal is equals to what? 1 minus the probability of E bar. My E bar is now stat or cal. Why this make easy? Because you know the answer already for probability of stat or cal. Exactly part C, right? This is the one we found in part C. Am I right?
Yeah.
Yeah, look at the part C problem. Finding the probability of the student takes stat or cal. That is the one here I want. So you already have that answer. What was the answer we got for part C?
0.83.
0.83. Therefore, simply plugging 1 minus for that one, simply plugging 0.83. If you understand this concept easily, you see now you have only 2 steps. Am I right? So therefore, answer is 1 minus 0.83, which is 0.17. What was the key here? The key was this formula, right? Now here they are asking one question, right? Did you note this question? Are the events taking statistics and taking calculus independent? What do you think?
Whoa.
If you look at now, you know the independent thing, under which rule we have independency? You remember, for the mutually exclusive, we use addition rule, right? Rule number 1 and 2. But for the independency, we use the product rule, remember? So you look at your notes, under the independency rule, we use, note that the probability of 2 events A and B is simply the product of A probability and the probability of B. So if A and B are 2 independent events, okay, if A and B are 2 independent events, then P of A and B should be always equals to P of A times P of B, okay. Now check whether this formula giving correct answer for the problem. If you are getting both side correct answer, that means A and B are independent, okay. In this is there in your class notes, so please go and check A and B formula,
So
right?
right.
Yeah, let us check. I'm assuming my event A as choosing statistics subject, event B is choosing calculus. So I'm going to find first A and B, probability of A and B. Okay, I'm going to find that. What does mean by that? That means the probability of choosing statistics and calculus. What was that probability we got? Stat and calculus. Students taking both. How many are there? 13. So this probability is 13 over 100, right? Okay. Now that is for P of A and B. Okay. This answer for P of A and B. Now I am going to find P of A and P of B. Let us find those two. What is P of A? Probability of stats. How many of them are taking statistics subjects?
I think it's 73.
75.
Oh, 75. I knew it was in the 70s.
Yeah, 75 out of 100. Then what is the probability of B? That means the probability of calculus. What is that? 21. Right?
Okay. Yes.
21. Okay. Now I have all 3 numbers here. Probability of A and B, probability of A, probability of B. If A and B were independent events, then this formula should be correct, right? So ask yourself, is this formula correct if you put these all 3 numbers there? Will it be correct formula? So formula says what? Formula says that P of A and B should be equals to P of A times P of B. Now tell me, what is P A times P of B? I have both of the answers are here, right? What is my P of A answer? I got 75 over 100. What is my P of B answer? I got 21 over 100. Check your calculator and find out this answer. What is the answer you will get when you multiply these two numbers? 0.1575. Okay, so that is the answer I am getting for the product. But what was my answer for P, A and B? What was the answer we got for P, A and B? P, A and B is here, 13 over 100. Am I right?
Yeah.
If the formula is correct, you should have these two same answer, right? But I'm not getting same answer because this is 13 over 100 is 0.13. Am I right?
Yeah.
P, A and B. So P, A and B is 0.13. PA times PB, I got 0.1575. Since these two numbers are not equal, that means your A and B even should be what? Not independent. Dependent, yes. It is going to be dependent. Do you see why now? Because this formula is not satisfying. This formula is not coming correctly. If A and B were independent, you would have got these two same answer. Am I right?
Yes.
Yes.
Is there any other way to check if it's dependent or independent, or do you have to do all this?
There is another way. If write down somewhere else, right? This is the basic way I explained you, but the easy way is this. If A and B are independent, okay,
Okay.
that means if the probability of B over A, if the probability of conditional probability, if this is equals to B of P of B, whatever you have here, right? That means what? If you see these two numbers are same number, okay, that means these two are going to be independent. If you are not getting same number, B of B given A and B, then it is going to be dependent. You could check that here also, right? Suppose if your B is stats and A is cal, you could choose any one of as B. If you want, you could choose B as calculus. Doesn't matter. You could switch, right? No problem. Okay, but now the B is now choosing statistics, A is choosing calculus. So find this probability, plugging these two events here. Okay, if the probability of my event E is stats given calculus, okay, do you know the answer of this? We got this answer. The probability of statistics given calculus, that was which part?
0.1575.
Say it again, which part that was? The first one, right?
Yeah.
Part A answer. Part A answer. Yes. How much you got?
0.6190.
Yeah, 0.619. That was the answer for B over A, stat given calculus. Now, what is the probability of statistics we got? That is 0.75. Are you getting same answer?
No.
No, that means that is not independent, dependent. This is another way, okay? It is dependent.
Is either one is dependent on each other, right?
That's the meaning.
Okay.
Yeah, that's the meaning, right? That's why I'm getting two different answers. Okay. So please, think about this. I understand this conditional probability is not going to be easy, but once you understand the concept, then that should be okay, I think. And let me know if you have any more questions, right? Okay, that is there about problem number 2. For problem number 3, it is always easy to make a table like I gave you in answer, right? So you could put everything under the one picture, right? Put everything under one table, then it should be easy for you guys to think about that, right? So if you look at your answer key, I just included the table. So table will make always easy to understand, okay? So if you put this all piece of information in table, so the table looks like this. So I'm making the table here. You are going into the classroom. There are 27 in total. You are choosing only one student, right? The student should be a senior or female. Okay? So remember, Part A is about probability of A or B. So you need to find now two things. The probability of a senior. This is the question now. You see, there are two events. You could think of this is event A and this is event B. Since, these two events are not mutually exclusive. Why this is not mutually exclusive? These two can happen at the same time, right? The selected students may be senior and female. Possibilities there. Therefore, these two events are not mutually exclusive. Therefore, you have to use the rule number 2 formula. That is, the probability of A or B is equals P of A is senior, plus P of B is female. Now you have to subtract the probability of senior or female, right?
Yes.
Okay. Now find this probability. That's it. Now tell me, what is the probability of choosing one is senior? Look at the senior column. How many seniors are there in total?
15.
15. Yeah. So this one is 15 out of 27 in the class. Plus, how many female? Look at the female column.
10 over 27.
Yeah. Then subtract the overlap. Oh, you see, I am writing wrongly. This is not or. That should be and. So how many students are senior and female?
5 over 27.
5 over 27. That's it. Now simplify this fraction and you will get the answer. So 15 plus 5 is 25 minus 5, which is 20 over 27. Okay. So I'm using rule number 2 formula. Rule 2.
So, and then because you can't simplify that, it just stays 20 over 27.
Yeah, that's fine. So you could leave in either way. If you want, you could type in the decimal or leave it like that.
Okay.
Okay. So the same procedure for the second one also, right? But the second one, now this is the catch. Are they mutually exclusive, these two?
No.
Think a little bit. Is that possible to have these two at the same time?
No.
No. Either should be junior or senior. Therefore, these two are mutually exclusive. So you have to use now rule number 1 for here. Remember here in the first part, this was mutually not exclusive. Therefore, I used rule 2. Now this is mutually exclusive. I am using rule 1. Rule 1 is much simpler. So the probability of junior or senior is simply the probability of junior plus the probability of senior. Okay. Now what was the probability of junior? How many juniors are in there in total?
12 over 27.
Yeah. Plus how many seniors?
15 out of 27.
That's it. So you should get 1. Yeah, that is sure. You should get 1. Why it is 1?
15 plus 7. Yeah, okay, yeah.
Well, yeah, in practical it should be 1 because you are going in the classroom inside and choosing one student. Only 2 possibilities are there, either junior or senior. So the selected student for sure should be either junior or senior. That's what you are getting 100% sure. You are going to get either junior or senior. Only 2 possibilities, right?
Yeah.
Yeah, that's why 100%. So the probability is 1. Now, could you go ahead and read the problem number 4? Okay, number 4. In an election, 47% of eligible voters did not vote. In research, they say that 47% of the people, they did not vote. If 3 eligible voters are selected, we are going and randomly choosing 3 people. We don't know whether they have, voted or not, right? But you know the chance now. 47% chance is the chosen one maybe, did not vote. We don't know, right? So the given information says what? This information says the probability of choose one did not vote is 47%. That is, if you change 47% into number, divide by 100, that should be 0.47. That means there's a 0.47 chance of the chosen person did not vote. That's the meaning, right? Okay, now remember you are choosing 3 people. Remember, all three are independent people, right? Am I right?
Yeah.
You are choosing three different people, right?
Yeah.
Therefore, you could consider all three events as independent events. Okay. Now, what is the question? You see, now you have a hint here. The probability of did not vote is 0.47. That is the one I explained here because of the given information. Okay. Now, what was the first part? The probability that none of them voted in the election. What does mean by that? So the question is now, you need to figure out the probability of what? None of them did not vote, right? That means what? That means how many people we choose? We choose three, right? All three did not vote. That's the meaning, right? That means the first person did not vote, and the second person did not vote, and the third one also did not vote. This is the meaning. Am I right?
Is this the one where you like for 3 people you'll cube it?
Exactly.
Oh yeah, yeah. I mean, this is making sense now.
Makes sense. Remember, I'm explaining. None of them did not vote means what? All three did not vote. First one and second one and third one. So now you could think of all three events here as a independent event, right? This is your event A, this is your event B, and this is your event C, right? Go and check your notes. If you had the probability of A and B independent, if they are independent, so the probability of A and B is always going to be equals to what? The probability of A times product the probability of B. You could use this formula only if A and B are independent. Yes, I know all three people are independent people. Therefore, I'm using this formula. Here I have written for two events. Now, instead of two events, I have three events. Therefore, simply multiply all three. Probability of A times probability of B times probability of C. That's it. Now, ask yourself, what is the meaning of PA? The probability of first guy did not vote. What is the chance of did not vote? You know that. Chance is 47%, 0.47, right? So the first guy did not vote. Chance is 0.47. What about the second guy? Yes, he also has the same chance. All three did not vote. Number of chances, right? What does mean by that? That is simply cube 0.47 to the power 3. Does that make sense?
Yes.
Yes. So now type this into your calculator, you will get. So whenever you see and, try to write the product. Whenever you see or, then you write plus, additional rule. So what is that? That should be 0.104. But the second part is now different. Second part, the probability of what? At least one. The probability of you are choosing three. At least one of those three, right? What? Should voted in this election. At least one voted. This is the question. Now I already told you, if you see at least in your problem, it is always easy to write down. It's the complement event. So if you think of this is the event, if you think of event E, the complement formula says that P of E is always going to be equals to 1 minus P of E bar.
Yes.
Okay. Now think and tell me what is E bar here. You know event E. Event E is
0.47.
you have to explain first in words. Tell me, if your event E is at least one of them voted, then what is the event E bar? I'm telling you, hey, at least one voted means what? At least one, or one maybe two, maybe all. But I'm asking you the negation of that. That means the negation of at least is always going to be none of them.
Oh, yeah. I see. I didn't even think about that one.
Oh, yeah. So keep in mind, at least one means the complement of at least one is none of them. None of them voted. So that is the event E bar. If your event E is at least one voted, then E bar is going to be none of them voted. That means what? That means all three did not vote. That's the meaning, right? None of them voted means. Does that make sense?
Yes.
Yes. That means I'm changing at least one to none of them. That means in words, 1 minus P of E bar means the probability of none of them voted. So the complement of at least one is none of them.
Gotcha.
Okay, good. But very easy now. We know the answer of probability of none of them voted. This is the part we got in previous. You see the first part, part A. We already found the probability of none of them voted. What is the answer we got for part A?
0.104.
Exactly. That means this answer is you don't need to do. You already have from part A. That is 1 subtract the part A answer, 0.107. Am I right? The thing is now, this is the difficulty we have in probability.
0.04.
Say it again.
It's 104, not 107.
Oh, so then what is the answer?
0.896.
Yeah.
Okay.
Yes.
Okay, good. So now if you have, you could take some short notes with you, so write down somewhere else. If your event E is none of the event E is at least one, then E bar is always going to be none of them, right? Now number five, if two cards are selected from 52 card deck without replacement, you understand that, please? You are taking one card and checking the card and you are not putting back. You are keeping out, right? For the second time, you have only 51. You understand?
Yeah.
So that means when you draw two cards without replacement, those two events are going to be dependent events because you are not replacing. Okay. Now you are drawing two cards. The first part is what is the chance of both are kings. That means you are choosing two cards one by one. The first should be king and second also king. That's the meaning, right? Okay. Now, which formula you are supposed to use?
The product one.
Say it again.
The product one.
Product. Under the product, again, you have two rules. Rule number 1 for independency. Rule number 2 for dependency. Which one you are going to use?
I think it's the dependency, right?
Very good. If it is dependency, then you have to use the conditional probability formula. Do you have your class note with you now? Suppose if this is my event A, if this is my event B, then probability of A and B is P of A times P of B if it is independent. But now we know these two are dependent because you are not putting back in second time, right? Therefore, the second time answer is now definitely going to be affected by the first one. Therefore, these two are now dependent events. If it is dependent events, P of A and P of B is simply what? The probability of P given A times P of A. Right? Please check your notes. This should be there in your conditional probability lecture notes. Right? Which formula I am using? I am using P, A and B is equals P probability of second event given the first event already happened and times the probability of first event. Okay. Now if you use this event here, could you explain in words the probability of first king and the second king is equals to what? So you could write here. I have written in A and B. Could you explain in words what is my event B here? Event B is choosing second king, right?
Yeah.
And event A is choosing first king. Therefore, if you rewrite this in terms of sentence or words, the meaning of this is what? The probability of second king You already know that first you have chosen king, then times the probability of first king.
So basically, like probability of B with the respect of A.
Exactly. Now I'm going to find this guy, okay? I'm going to find this probability. Now ask yourself, what is the meaning of that? Basically, you are finding the probability of second one is king. You are choosing the second card, that should be king. But you assume that you already choose the first time king and you are not replacing, right? That means let's see who's telling them what is this probability. What is the probability of choosing second king? Provided the first one already you have chosen as king.
That one would be 3 out of 51.
Exactly, very good. So this going to be 3 over 51. Why it is? Because you already assume that first time you chosen king. There are 4 kings in card pack out of 52. You have already chosen one, keeping outside. So there are 3 left over out of 51. That's the meaning. Very good. That is my first probability, right? Then times, what is my second probability? The probability of choosing first time king.
Oh, 4 out of 52.
Very good, because first time you will have all 52 cards in your card pack. Therefore, you are free to choose any of 4 possible kings. So that is 4 over 52. Does that make sense? Others? Do you understand? Yes. That means if 2 events are dependent, second time is always going to be less than the first one. Yeah, that's it. So simplify these fractions. 1 over 221. But if you want, you could do in shortcut method using the tree diagram. Draw the tree diagram. This is for first card. This is for second card, right? I'm looking for king first time, but remaining all going to be non-king. And here second time also I'm looking for king. So this is non-king. And again king, okay? So if you want, so you could use this kind of tree diagrams to do the problem. So now here put the probability of what? Probability of choosing king first time. There are 4 kings out of 52. That means what is the probability of choosing none of them are kings? That means remaining 48 is going to be non-king out of 52, right?
Yeah.
But if you look at this, the second branch here, you have to put the probability here. What is the probability? This king branch is coming from where? From the first one. You already assume that you're choosing king. You are choosing only one king first time. So the second time probability here should be what? Remaining 3 kings out of 51. That makes sense? Choose the probability of the second time king. Now this is the one I am looking for. Simply multiply these two numbers. 4 over 52 times 3 over 51. That is the one I got now. Here. Okay. So this is just a shortcut using the tree diagram. Suppose if this your event E, what is your event E here? Choosing the different card. So the probability of choosing a different card is always going to be 1 minus, I'm using the complement formula because it is easy. The probability of choosing different card is always 1 minus P E bar. Then what is E bar? If your event E is different, then what is your event E bar?
The
The negation of difference. All are?
All kinds of suits, all the suits.
Same, yes. So the negation of same is going to be, negation of different is going to be, the same. That means what? You are choosing 2 cards, right? So the probability of having different suits is always going to be 1 minus the probability of same suits. Okay? Now you need to find the probability of same suits. What is the meaning of the probability of same suits? What's the meaning of that?
That the cards will have all the same like suits.
Oh, that means if you choose 2 cards, maybe hearts, right? Or maybe clubs, maybe diamond, all same suits, right? That's the meaning, right?
Yeah.
So then how many possibilities are there? You have, suppose say you choose 2 cards, those 2 are say, coming from where? For example, say coming from hearts. So what is the possibility of having both of them are hearts? You are choosing first card, which is hearts, and second one also hearts. So what is the probability of those 2? So let me write down here. the probability of same means, right, that is 4 times of the probability of hearts, right, hearts and hearts. Why I am writing 4 times? Because you may have any four possible suits. Maybe one of them may be hearts, or maybe clubs, maybe spade, maybe diamond. So there are 4 chances for each. That's why I'm multiplying by 4. Now find the one. What is the chance of having first card choosing hearts and second one also hearts? How many hearts there are in card pack? There are 13 of them out of 52 first time, right?
Yes.
But second time you have only 12 out of
51.
51. So this is the probability you have for both of them are hearts. I have written the answer only for hearts. You will have the same probability for what? For the clubs. You will have the same probability for diamond. And you will have the same probability for spades. So all 4 have same possibility. That is why I multiplied by 4 to get all possibilities. Do you understand that point?
Yeah.
Yeah, therefore the probability of getting same is 4 times of this. That is why if you look at my answer, I have written here 4 times 13 over 52 times 12 over 51. Okay, now simplify that one, and you should get, what is the answer actually? You should get 13 over 17, am I right? Read the problem carefully. In a board of directors composed 8 people, there are 8 people. In how many ways can one chief executive officer and one director and one treasurer be selected?
Oh, yeah. So it is. You're asking about individual group, right?
Now you see, we need to choose 3 from 8. That's for sure. But are you going to put in order of 3 1?
Yeah.
Yes, because order is now important. Order is what? Here in this problem, order is nothing but the title of the job, right?
Yeah.
So you need to have, chief, the chief executive officer and one director and one treasurer. So you are choosing 3 people, but all of them have different ranks, right? So that means now order is important, right? You could choose the same 3 persons and you can put into different orders, right? So that means order is here important. Do you understand that part? So make sure that, before writing, into NPR or NCR, make sure that you understand that concept. So
Yeah.
in this problem now, order matters.
Okay. Yeah.
Because the rank given for the job. Okay?
That so you won't have like 3 executives chosen, right?
Exactly. Now tell me what is the ways. So how many ways you could make this? There are total 8. You are choosing how many? 3.
3.
So that is 8p3. Go to math.
Probability, right?
Yeah, first type the number. First type 8.
Yeah, 8.
Then go to math. Then go to the number 4, PRB.
Yep.
Then you will see their second choice is NPR. Then enter, and they enter the second number 3.
336.
Yeah, you see now there are 336 ways we could to make that, the number of ways, right? The next one is, do you understand which formula you are supposed to use, number 7? Conditional, right?
Yes.
You see now, question is find the probability the students taking physics given. So you have to use the conditional. He is taking a sociology. The question is now the probability of the student studying physics given that he is taking sociology. So make sure that you understand. So therefore, I am using the probability of given formula. So the probability of P given A is given by P A and B divide by P of A. I'm using the conditional probability formula here. So therefore, my event, if you compare this formula with the problem here, my event B is physics and my event A is sociology. Therefore, if you plugging those A and B here into that problem, you will get the probability of event A is sociology, and physics. Then this all divide by the probability of A. A is now what? My event A is sociology. Okay. So this is my event B and this is my event A. So now simplifying these answers. So what is the probability of sociology and physics? Do you know that? The probability that students takes physics and sociology is given 0.18.
Yes.
Therefore, the probability of first one is 0.18. Over. Do you know the probability of sociology?
0.72.
Exactly. Of course, you have been given only two numbers here, but you need to know which number is supposed to come in denominator, right? So you have to put into a proper place. So this should be 0.25, right? Okay. So the next one. In how many ways? Oh, now making comedy. Number 8 should be super easy then. When you make a comedy group, does order matter?
Yeah. So that's the one where it's the same thing as number 6, right?
No, 6 and 8 quite different.
Oh, it's the opposite. The one with the C then?
Exactly. They don't talk about the order. I don't want order. You just choose 4 different, you are looking for different groups. You are not putting into order. Therefore, are they talking about any arrangement, any something random? No, no. So the order is not important in this problem. The order is not important. Use NCR.
So it'll be 10C4?
Exactly. So 10C4 is 210. So there are 210 ways you could make the group. Different combinations, in another word. Okay. There is 8. Number 9. Okay. Number 9. Again, how many ways? Oh, now number 9 is little bit different. In how many ways can a jury of 6 women and 6 men can be selected from 9 women and 12 men? Now you are going to perform 2 experiments. First you need to choose, so the number of women, then you are going to the men, right? So that means you are doing 2 experiments. You need to find out, separately for each experiment how many possible outcomes. After getting 2 answers, then you have to multiply them to get the final answer. Does that make sense? So first, ask yourself, what is the experiment you are doing first time? First time you need to choose women, right? How many women are given in total? There are
6 women.
6.
Or from 9 women, choosing 6.
Yeah, you need to choose 6 from 9. So there's 9 choices, but we are choosing 6 from them, right? Therefore, in how many ways you could choose those? Are you talking about the order?
No.
No, no order. Therefore, NCR. So choosing women will be how many ways? 9, choose 6. Am I right? Then multiply this answer. This is only the first experiment. This is for just the first experiment, choosing women. Then you need to multiply the second experiment. Keep on multiplying by your number of experiments. I'm simply using here counting principles, K1, K2, K3 formulas, right? Remember, I'm doing 2 experiments. Therefore, I will have 2 numbers, K1 and K2. My K1 is now 9C6. But what is my K2? The second experiment weighs. How many men we need? 6.
12C6.
12C6, yes.
924.
Yeah, now simply multiply these 2, okay? So you understand the question carefully and ask yourself how many different experiments we need to do, find separately, then multiply them out. So answer is 77616, right?
Yeah.
Yeah. So many ways, no? Oh, now look at that. Number 10. Number 10, we are going to use this NCR, NPR formulas, but you are going to connect those numbers into what? Into probability now. You have to understand, this is the place most of the students, make mistakes. If you look at number 9, are they talking about probability? Do you see any word probability there in the question?
No.
No, they don't ask any probabilities, just the ways, number of ways. But number 10 does. They talk about, the probability. You see the words now, probability. Okay? Whenever you see counting numbers probability questions, you need to use what? That's the classical probability formula. So you have to use this formula. P of E is always going to be N of E over N of S. The very basic formula we studied under the probability topic in this course. Probability of any event E is given by the number of possibilities from that event divided by number of possibilities from your sample space, all the possibilities. Okay, you have to use this formula now. So let's look at this problem. What was the given information? A bag contains 5 red balls and 7 white balls. So there's a bag. There are 5 red balls. Let me denote red as R, and 7 white balls, that is W. If you randomly draw, how many balls you are drawing from there? 4, right? Simultaneously, you are drawing 4 balls and you are keeping. We don't know what kind of 4 it is there. Maybe all red, maybe all white, or maybe all mixed, right? We don't know, right? Now, what is the question then? Find the probability that this is the event we need. This is my event E. What is that? If you look at this problem and if you write in symbolic way, you need to find the probability of what? The probability that you get 2 red balls and 2 white balls. 2 red and 2 whites. Okay. Now I'm going to use this formula and think a little bit and tell me, you are drawing how many balls? 4 balls. What are the possible ways to choose 2 reds and 2 whites? You are choosing 4 balls. So I'm explaining here, okay? My event E is what? My event E is choosing 2 red and 2 whites. Okay? So I'm looking for now 2 different experiments. First, you need to look at the number of ways you could choose 2 reds. Okay? How many ways you could choose 2 reds? How many reds are in total?
5.
5. Out of 5, you need to choose 2 of them. How many ways you could perform that experiment?
Is it where you got to use the
5, 3, 2.
Yeah. Okay. Oh.
Because you are given 5 red balls, you are choosing 2 at a time. In how many different combinations, group you could make? You could make 5C 2 ways, right?
10.
Are you putting into order? No, they don't take about the order. They just ask us to collect the balls. That's it. No ordering, just combinations. So NCR formula, right?
Yeah. So I got 10.
Yeah, that's 10. Yes, yeah, correct. So remember the problem, decompose the problem into 2 different pieces. So you have to consider now 2 different events. My first event is what? Choosing red color, red balls, 2 red balls from 5. So there are 5C 2 ways. Now move to the second problem, second experiment. Now you need to choose 2 Ws, 2 white balls out of 7. How many ways you could perform that one in there? 7, choose 2.
Yeah.
Right? So choosing red ball is 5C 2 ways, choosing white ball is 7C 2 ways. When you multiply these 2 them out, then you will get total number of ways choosing 2 reds and 2 whites out of how many balls? In total, 12 balls. That makes sense? Yes, this is not easy, but still,
It's complicated.
yeah. That's what we studied, that making groups, NCR and PR formula, right? Okay, this is only I'm talking about event E. So event E could be performed in 5C2 times 7C2 ways. Okay, now let us move to your samples. Sample space. What is my sample space? Collection of all possibilities. How many total balls you are drawing? 4 out of 12. Exactly. This is the catch. You are given, sample space means you have to talk about, the entire possibilities, the total ways, right? That is the sample space, no? All possible outcomes. What are my all possible outcomes? You are given 12 balls, you are mixing all 12, and you don't know what kind of force you are going to take, how many different force you could take. You could choose 12, choose 4 ways. Why it is 12 choose? When you talk about the sample space, you have to put the total possible balls given and the total number of balls you are picking. That makes sense?
Yes.
Yeah, you see now. This is the case. If you are finding the ways for the sample space, always think about the total. In whole picture, you have to think about, right? So in total, you are given 12 balls. Out of 12, you are choosing 4, right? For your explanation, this is the way to, get some, the understanding about the actual thing is happening here. What was that? This is the thing. You see, you are given 12 balls, right? So you are drawing 4 balls. Okay, could you tell me one possibility? I'm giving you 5 red and 7 whites. In total, we know there are 12 balls, right? You are mixing all 12 and we don't know. You are just picking 4 of them, okay? 4 balls, right? Could you tell me one possibility? One possibility is you could choose 1 red ball and 3 W's. Am I right? Or you may choose 3 red and 1 W. Or you may choose 2 W's. Or you may choose all 4 reds. Or you may choose all 4 W's. So many ways you could choose 4 balls from W. Am I right?
Yeah.
One of those is 2R, 2W. This is the one they are asking us. Hey, what is the chance of having these kind of possibilities? 2R, 2W's. You will have so many ways. They are asking us one of those. Okay, so this is the event now we are looking for. Even though you have so many possibilities, you are looking for this event E. This all, if you consider everything under one picture, this is my sample space. Do you understand now?
Yeah, all that is a sample space.
Exactly. That is why sample space means you have to think about everything together in one picture. Therefore, that is why I have here for the sample space, you are given in total 12 balls, you are choosing 4 in total. So how many ways you could perform that one? 12 choose 4. Does that make sense? Right. Now remember, question is finding the probability. So I'm going to use this formula. The probability of event to choosing 2R, 2W is simply the number of ways you could perform the event E, then divide the number of ways you could perform the sample space, the entire picture. So the entire picture can be done in 12 choose 4 ways. For event E, I could perform in 5C2 times 7C2 ways. Therefore, answer we are writing fraction. First write the possibilities for event E. For event E is 5C2 times 7C2. Okay, times 7C2. Then this one you need to divide by sample space possibilities. My sample space possibilities is 12 choose 4. That is why if you see your answer, 5C2 times 7C2 over 12C4. That makes sense now?
Yes.
Yeah, so now take your calculator and simplify. So that is 210 over 495. So that is going to be 0.42. Okay. Number 12. This is from chapter 5, right? So now let's move to chapter 5.1. this is about the, you are given a distribution table. You need to check whether this is a probability distribution. How do you check? Remember, if the given distribution is a probability distribution, you have to check two conditions. Condition number one, if we add all possible probabilities in the table, always going to be what? 1. It should be always 1. The second condition is individual probability. Each and every probability answer in your table should be always between 0 to 1, inclusively. 0 and 1 included. Check these two conditions. If both of them are satisfied, then only you can say that the given distribution table is probability distribution, right? Any one of these is not satisfied, then you don't need to check even the second one. Then you could right away tell that it is not, the probability distribution table. Okay. So let us check one by one then. I'm going to check the first condition. Let us check this condition. Look at the table given. Add all the possible probabilities. There are 3 possible probabilities, right? So I'm checking now the probability of the summation. So first is 1/2 plus the second one 1/3, and my third probability is 1/6. Take your calculator and simplify. Are you getting 1? Type all together, okay? Don't round up. You should not round up. Yes, that means the first condition is satisfied. Well, now move to the second condition. Now check individual probabilities. 0.5, that is less than 1. 1/3 is approximately 0.33. Yes, that's also less than 1. 1/6 should be something like a 1.2. So that also less than 1, right? Therefore, all the probabilities values are satisfied between 0 to 1. So second condition also correct, right? All the probabilities are 0 to 1. Therefore, all 2 conditions are satisfied. So the given distribution is yes, probability distribution. The answer is yes. Reason is these 2 conditions. So if you are asked to check whether the given probability given distribution is probability, make sure that you are showing up these 2 work. Okay. Okay. Now the second one is you are given a probability distribution. That means they are telling already it is a probability distribution. So you don't need to check. Okay. It is a probability distribution. So you have to assume that that is a probability distribution. So you don't need to check. By assuming this probability distribution, okay, now remember, if you look at my notes, if you are given probability distribution, it is always possible to find mean, variance, and the standard deviation for that variable x. Remember, this table, describes how you have distributed your probability values among all possible x values. So if you look at all possible x values, your variable x now may have 5 different values, 1, 2, 3, 4, 5. The probability of each value occurs is given here, right? You know the probability for each individual. How do you find the mean? Mean of your variable x is given by this formula. Look at the hint. So use the formula for each case and find out. So let us find. First I'm going to find the mean. Mean for what? Mean for x, the variable. We use mu for mean. Formula says what? Mu is given by the summation. Summations means you are going to add what? The product of your variable value times its corresponding probability. Okay. So take one by one. Take the first x value. What is my first x value? Which is 1, right? Then what is the corresponding probability? 0.27. So simply multiply these 2 numbers. So 1 times 0.27. So this is one answer. Then summation means you have to add, right? Then put the plus sign. Now go for the second value. My second x value is 2 and its corresponding probability is 0.46. Therefore 2 times 0.46. If you want, you could put into parentheses, right? And so on. And my third one is 3 times 0.21, and my fourth one is 4 times 0.05, and my last possible x value is 5 times 0.01. take your calculator and simplify and write into 2 decimal places, 2.07. That means this is the mean of my random variable x. It's super easy, no? You have the formula, simply plugging the values in. The second one is what? Finding the variance. Where's the formula? We use the sigma squared. Formula says that, hey, find the summation of the product of the data value squared times its corresponding probability. Find the summation first, then subtract the square of its mean, the mean answer you got earlier. Okay? Understanding the notation. Now what do you want to do? Now you need to take one by one the data value, x value, but you have to square them. My first data value is 1, square that, 1 squared. Now multiply by its corresponding px, the probability is 0.27. Okay, then summation means you need to keep on adding. The second data value is 2, but squared, times the corresponding probability is 0.46. And the next one, 3 squared times 0.21, and plus 4 squared times 0.05, and the last one, 5 squared times 0.01. These all will give you what? These all will give you just the summation, right? But you need to subtract the mu squared. Now mu answer we got for the previous part is 2.07, but you need to put the square. Okay, now take your calculator and type this all, and if you do it correctly you should get 0.77. So that is my variance. Once you have variance answer, it is always easy to find the standard deviation, right? Simply find out the square root of your variance. So the variance answer we got was 0.77. Take the square root of 0.77. This would be roughly 0.88. Okay, my suggestion is when you do the test, make use of, write down as much as possible steps, okay? Rather than writing one word answer, try to explain in words. Then even though your answer is wrong, you may have some more extra points, credits for your work, okay? So question number 13. 13 comes from, where's that? It should be from 5.3, I believe, binomial distributions, right? Have you gone through my lecture note about binomial distribution? Okay, let me go through very quickly here, and otherwise you will not understand, okay? What is your task? What are you looking for? How many possible outcomes you may have under binomial experiments? This is for your information. Let me grab the lecture notes. I'm just showing for a couple of minutes, and otherwise. Okay, you see the highlighted part? So if you are doing some kind of experiment, and if your experiment satisfies these all 4 conditions, that means that experiment is called a binomial experiment, okay? A binomial experiment is the probability experiment that satisfies these all 4 conditions, okay? The number of trials, the number of experiments you perform should be a finite number, fixed number, right? First of all, you have to fix your mind. Okay, I'm going to do only maybe 10 times this experiment, which is called the trials, right? The number of trials. Each experimental trial can have only 2 outcomes. When you perform an experiment, you should have only 2 possible outcomes. For example, tossing a coin, right? When you toss a coin, of course, there are only 2 possibilities, right? So we will get either heads or tails. Am I right? So that those kind of experiments are called binomial. Always you have to have only 2 possible outcomes. Okay? The outcomes of each trial must independent of another. So all the trials, whatever you make, all should be independent events. The probability of success means what? Whatever you are looking for. For example, you see, I'm tossing a coin 50 times, and I'm looking for the number of heads, right? Whenever I get heads, I'm happy. That is my, the one I'm looking for. So if I get, heads, I succeeded in that, the experiment, trial. Whenever you get tails, that is the one I'm not looking for, right? So then it is considered like a failure. Okay? So each trial, the probability of success should be same. Yes, that is correct. When you toss a coin 50 times, I'm looking for heads. The number of, the probability of getting heads for each trial, single trial, is half, right? 1/2 chance. So throughout the 50 trials, I will have same probability of success, am I right?
Right.
Yeah, so those kind of experiments are called binomial experiments, okay? Since, if you have binomial experiments, and it is always advisable for you guys, why don't you go through the lecture notes first before, trying into that problems? You should understand the notations first, okay? So here I have given some notations. We use P of S for the probability of success. In another word, we use that as a little p. Little p means the probability of success for each trial, for single trial. Little q is the probability of failure. When you add the probability of success and the failure, it's always going to be 1. So in another word, p plus q is always going to be 1. Okay? Little n is the number of trials you are fixing in your mind. So n is a fixed number. X is the variable. Whatever we are looking for, if you look for the heads in tossing, that means the number of heads you are looking for throughout your n experiments or trials, that is going to be your variable now. X, number of trials you are looking for, a number of successes you are looking for. Okay? So make sure that you understand. Then the probability of number of successes given by this formula. The probability of number of successes x is given by n factorial over n minus x factorial times x factorial. This is nothing but n choose x. Okay. So let me go there, and I'm writing here. Suppose x is the number of successes you are looking for, right, in n trials. Then probability of getting that number of success x is given by n choose x times the probability of success for single trial to the power x times the probability of failure to the power the total number of trials subtract the number of successes you get. That means this is basically the number of failures, right? So this is the formula we are going to use if you are asked to find the probability of a number of successes at the binomial distribution, binomial experiment. Okay. Suppose if you have the variable which is a binomial, then we could find mean, standard deviation, and variance of this variable x. The mean of the binomial variable x is given by mu, that is n times p. If you are asked to find the variance of a binomial variable, that is simply n times p times q. And the standard deviation of the binomial variable, little sigma, that is simply the square root of your variance answer. This is variance. That is n times p times q, right? In summary, what can I say is, if you want to find mean, variance, and the standard deviation for the given problem, binomial, first make sure that the given experiment is binomial. Then you need to figure out some numbers. You need to figure out n, p, and the little q. Find out these three guys. What is the relationship between p and q we have? If we add p and q, the probability of success and the probability of failure is always going to be 1. Okay. What is n here? N is number of trials you make in total. Total number of experiments or trials you make. Okay. Number 13. Find the mean, variance, and the standard deviation for the number of heads when 10 coins are tossed. You are tossing 10 coins simultaneously, and you are looking for the number of heads. Maximum number of heads you may get is 10, right? Because you are tossing 10 coins, once each. Does that make sense? Therefore, tossing a coin is going to be binomial experiments. So you could use the binomial experiment formulas. And the only thing is, as I said earlier, you need to figure out these numbers now. NPQ. Okay. Let's see who is telling. What is little n for this problem?
10.
10. You are performing 10 experiments, 10 times, 10 coins you are tossing, right? Therefore, n is 10, right? Then what is little p here? The probability of single experiment success. What is our task actually? You are recording the number of heads you are getting, right? Am I right? So you are counting how many heads out of 10 tossing you are getting. That means my variable x is here, the number of heads.
1/2.
1/2. Remember, definition says that little p is just, you have to consider only a single experiment. You assume like you are tossing only one coin, right? When you toss a coin, what is the chance of getting heads? Because you are looking for the number of heads. So your aim is to get heads, right? When you get heads, we are happy, succeeded. So what is the chance of having success? That means getting heads when you toss a coin once, it is 1/2. If your probability of success is 1/2, then what is the probability of failure? You are telling that to succeed that you are getting half chance, 50%. The remaining 50 going to be failure, right?
It'd be 1/2.
1/2. So like that, figure out NP and Q. Remember, as I said earlier, if you know P answer, P is 1/2. It is very easy to find Q by subtracting 1/2 from 1. Why it is? Because when you add P and Q, you should get always 1. Okay? So it is easy to find Q once you know P. Subtract P answer from 1 to get Q. That is 1/2. Okay? So we know all the numbers. Yes, we got all three numbers. That's it. Then find one by one. What is? Oh, you see the typo here I have? It should be mean, right? Not mean. There's a typo here. Could you change it to mean? How do you find mean? Formula says that mean is
10
what?
times 1/2.
Exactly. Formula says that mean is given by n times p. We got n as a 10 and the probability of success is 1/2. So 10 times 1/2, which is 5. Okay, that's not harder. Now let us find the variance. The variance formula says that simply n times p times q. What is n? Again 10. P is 1/2 and q also now 1/2. Simply multiply these three now. That is basically 5 times half. That is 2.5, right?
Yes.
Very good. That is variance. So we need one more thing, standard deviation. How do you find the standard deviation? Simply square root of your variance answer. Variance answer we got 2.5. Then find this answer.
1.58.
That's it. So now let's move to the last problem. Last problem is coming from 6.1, right? Normal distribution. This whole chapter 5 talks about discrete random variable. So there are two things actually you should understand. Chapter 5, just now we did binomial and all. This all coming under discrete random variable. You know the meaning of discrete random variable. Discrete means what? Your random variable x will have only finite number of values, fixed values.
And then continuous is if it's constantly changing, right?
Exactly. So for the chapter 5, we talk about the discrete. So your random variable like a binomial, you see now we are fixing the values, right? Trials, total number of trials. So you know your x for sure, x should be the limited number of values. In this example, we have how many different x values? We have 10 different x values. So fixed value. But Chapter 6 is about the continuous random variable. There are plenty of continuous random variable, but especially we are talking about here the continuous variable for the continuous variable which is about the normal distribution. Okay, so there are plenty of continuous random variable, but chapter 6 especially talks about the normal random variable. Normal random variable is a random variable, but which is a continuous random variable, right? Oh, for example, suppose if you want to measure somebody's height, you see, height may be any value, any decimal value, infinitely many values you may take, right, for the height, or even for the scores. Suppose if I want to find the score for somebody in decimal places, I could make infinitely many values, right? Therefore, scores, height, weights, those things are considered as continuous random variables. Okay. So now we talk about the normal random variable. There are some properties for normal random variable, right? If you find the distribution of a normal random variable, right? Remember we studied about the histogram and making the skewed, right skewed, left skewed, symmetric, those distributions. And the normal random variable always has this kind of properties. So if you draw a curve for the the normal random variable, it is a continuous curve. You could draw a continuous curve. That curve is very much symmetric about the midpoint. Okay, the middle point is called mean of your random variable. Okay, so we use mu, right, for the variable mean. So for your random variable x, you may have mean mu, and you may have mean mu, and you may have the variance sigma squared, right? So this is the property, these are the properties you have for the normal random variable. It is a bell-shaped curve and a symmetric curve, and this curve never touch x-axis, but going all the way, this axis value, right, any real value you could pick, any real value from negative infinity to positive infinity. So your random variable x may have any value between negative infinity to positive infinity, right? If you look at the distribution of x is like this. Okay, so you could go and check your 6.1 lecture note and you will understand everything. Okay, so this is all about the normal random variables. Remember in chapter 3 I believe we had the z-score, little z formula. In chapter 3 we had, right? Do you remember? The z-score of any random variable, normal random variable x, is given by x minus mu over sigma. Do you remember this formula, z-score?
Sounds familiar.
Yeah. In chapter 3 we learned.
Yeah, I got it written down right here.
Yeah. Now, what's the meaning of this? This formula will, z formula will change all x values in terms of z, right? If your x is normal random variable, if we have z is given by x minus mu over sigma, then little z is considered as a standard normal variable. Okay. If you have the original x value, we know already how to change x into z by looking at this formula. Okay, so the z is denoted here by the standard normal variables. Okay, so what are the qualities we have for the standard normal then? If you draw the distribution for standard normal, again it is a bell shape because it is also normal. Okay, but the mean, the middle point is now always 0. Okay, so for the z, for the standard normal, mean is fixed, always 0, and the variance is also fixed, always 1. Okay, if you see any random variable, normal random variable with the mean 0 and the variance 1, we name that normal random variable as standard normal z. Right, in summary, keep in mind, standard normal z variable has always mean 0 and variance 1. Okay, so if you draw the picture for z, mean is always 0 here. You could put here 0, middle point, symmetric point, right? Center point is always 0 mean. Okay, now this guy, they are asking us to find the probability of I think before that, I need to tell one more thing. Suppose if you are given a z distributed curve, middle point is 0, do you know how to find the area of a particular region? Suppose if I want to find this area, say this is 2. Let's see, any one of you, could you give me an answer? How do you find the area of this curve for the z distributed standard normal? How do you find? How do you find this area? Any idea?
You have to look it up on the table, don't you?
Exactly. Yes, that's what I wanted to. You could use the table and find the area. If you want to find the area under the standard normal curve, always you will be given a table. I already uploaded the tables in 2Review, right? So you could download those and make practice, or anyway, you could use the calculator as well to find the area of standard normal. I'm going to show in both ways today. Okay, so let us first use the table and find the area. So the first method, I'm going to use the table. Use the table provided to find the area between two particular z values. Now my z values for this area, my z values are 0 and 2, right? Okay. I need to tell one more thing. Under the properties of the standard normal, if you find the total area of this entire curve, the full curve, okay, the total area of full the standard normal curve, any idea how much it is? The full area of normal curve is always going to be 1, okay, or 100%. Okay, by symmetric, remember this curve, bell-shaped curve, and symmetric about 0, therefore this side half and that side half, because the total area is 1. So this side you have area of half and that side as well. That make sense?
Yes.
Okay, keep in mind those properties. Now remember, you are asked to find only this much area. Okay, so let us pull my table first. How are we going to use the table to find the area for standard normal? I need to look at where's my table. Okay, there are plenty of tables. We use table E. You see there, standard normal. This is the table we use. So the first column is always our z value. The z value may be negative because remember the picture is here. Z value may be negative also because 0 is here. So I need to zoom up. Okay. Do you see here 0? This is my z distributed curve. This is my center point 0. So anything beyond that point is going to be negative values for z. This side is positive. Therefore, if you look at your table, first column may be negative and going down, and this table values continues to the second page, and the z value here you see 0. Then again starting increasing, and the maximum c value is 3.4 in your table. Okay. That means what? That means if you pick any z value here, it will give you the area inside the table. These all area values, okay? Right? For example, suppose if you look at this value, 0.6179, what is the meaning of that? The meaning of this is, always the inside the value of your table always will be given what? The left side area to the point. Suppose if you pick the z value here, then you need to figure out the left area from that point. Left side area is always given in this table. You understand what I mean?
To the left side, it's only going to be the
Table value inside.
yes, sir.
Okay. For example, look at this. Look at this. Before going to do that problem, I just want you to explain small one. Okay. Suppose if I want to find this area, say this is 0, say this is 2. Okay. I'm going to find left side area of which point? This point. 2, right? So if you look at this value 2 in your table, then you will find the inside value as your area, left area. So the left area of the z value, which is 2, is given by simply look at the z value for 2. Okay. Okay, so where is my z value 2? Z is here. Where is 2? You have to look for the 2. So 2 is here, right? 2 means 2.0, right? 2 is here. So look at the first value here. This is the value I am looking for. So if you look at your column, it says that the 0 decimal place. Yes, 2 means 2.00, right? 0 decimal. If you want 2.1, then you have to look at 2 and 1. 1 is here. Decimal point 1 is here. So this is the way to catch. Now I need 2, therefore I am looking this value. This is the area I am getting, 0.9772. Okay, 0.9772. So that is the area you will get, 0.9772. So this is basically the area I colored here, left side area to that point 2. That make sense?
Yes, sir.
Yes.
Yes. Now you have to think a little bit. If this is the case, let's see who is telling. Then what is this colored area? I need only 0 to 2 area. So how do you find this area? You could make use of answer just now we got. Who's telling this area? What is that area?
0.8289.
Say it again.
0.8289.
Why it is 289? Could you explain in words?
If you go to the table E, 0.95, the area is that.
You see now, if you look at the answer just now we got, there's a relationship between this picture and that picture. Do you see that?
Yeah.
Okay, now I'm asking you, okay, what is this uncolored area? This side, how much? This side area, uncolored area. Anything left side to the 0. Just now I told you, 0.5, very good. I told you just now, the total area is always 1, right?
Right.
But because of the symmetric, anything left to 0 should be half. That side half. From here to here area is half. This area also half because of the symmetric. That means this color area is 1/2, am I right? Uncolored area, sorry. This is 1/2. Does that make sense? 0.5. Do you get that my point?
Is that why every value?
Oh,
below-
yes. For every z distribution area, anything beyond the 0 left side is half
Okay.
because of the symmetric. Because the total area is always 1 for full curve. Right? Now look at this picture. Just now we got anything left to 2 is 0.772. Am I right?
Right.
0.9772. Right? That
Right.
means from this point 2 to all the way that side. Full left side area to 2 is 0.9772. But if you subtract this half piece, left side area, this piece, you will get remaining the one just now I colored. That makes sense?
It does.
That means what I'm trying to say is if you subtract half from this value, you will get that value. Am I right?
Correct.
So this area is nothing but the one I got from left side area to the point 2, subtract the uncolored half. It is point
4772.
exactly. Do you see now how to find the area? That makes sense?
But if it's a value that's to the right of 0, but it's asking to go to the left of 2.
Oh,
then
that is the another question I'm trying to ask you. Okay, now tell me. Suppose if it is 2, what is the right side area to the 2 then?
0.9772 subtracted from 100.
Say it again?
Subtracted from 100. From 1.
Exactly. Very good. You know now left side area. This area we have found. You see about the curve here. Anything left to 2 is 0.9772. But total area is 100%, 1. So if you subtract this value from 1, you will get leftover area, right side area. Am I right?
Right.
So this area is 1 minus of your left side area. That is point to how much? 0. Are you getting my point?
0.0228, yes, sir.
Yep.
Okay. Now I need to ask one more question. I'm writing all the possible scenarios, okay? Now tell me, if I give you a -2, then what is this area?
It's just this area that's on the table. It doesn't change.
Okay, so you are going to change the table. You are going to look at the table, but your z value is now -2. Am I right?
Correct.
Yes, sir.
Okay, now if you look at the table directly, you will get the answer because table is always given the left side area to the point. Yes, I want now left area to that point. So table directly will give you the answer. Yes. So where's my table? Did I close that? No, it is here. So where's -2? I need a -2. Z is now -2. So it should be 2.0. You see, this is -2. What is the answer you are getting?
0.0228.
If you are very smart, you would have told very easily for me by looking at the previous picture. You see, we got the same answer earlier, right?
Correct.
Why it is? Because of the symmetry. Whatever you have left to the -2 should be right to the right to the +2 should be same area. Am I right?
Right.
Because of the symmetry of this curve. You understand what I mean?
I do.
Yes. Okay. This is the smart thinking. The way I am explaining you, okay? I'm asking you, okay, could you find out the area for positive 1.48, right? If you are very smart, remember, table will not give you right area. Table will give you left side area, am I right? So, but the question is finding right side area. What I am going to do, instead of finding plus 1.148, I will mark the point here, -1.48. If I could find this area, then this area and that area should be same because of the symmetry. Am I right?
Correct.
Oh, okay.
Yes. If you want to find the right area to the 1.48, it is equivalent to find the area to the left of -1.48. Okay? So now I know how to find left area from your table. Look at this value now. Left area for -1.48.
0.0694.
Let's see, -1.48. Table will give you 1.4 here, but where's the 8? 8 will be here. You see 8. the before last column, right? That's the one before last column. So I need 1.48. So how much it is?
0.0694.
0.0694. That means if this area is 0.0694, then what is this area? Same, right? Make sense?
It does.
Okay, very good. So far I explained everything without using calculator. But we have technology. Within a minute we could find the area, whether right or left or whether in between. Okay, so I'm going to show you how to use the calculator. This all everything clearly I explained in my video lecture note. So why don't you go and check, okay? So, okay, I will show you only one of these problem, okay? So let us, okay, let's see. Very smart question now. Let's see who's telling. I'm giving 1 minute. Could you look at this picture and find out the in-between area? What is the area from -2 to +2, the uncolored area? Could you tell me how much it is? I need only the answer, okay? Tell me the answer. Uncolored area, -2 to +2.
0.9772.
Your answer is in the picture. You don't need to do anything. Only you need calculator. I'm writing like this. Do you see my calculator there?
Yes.
Yes. Let's see. If I write like that, do you understand?
Oh, okay.
Is that understandable? What I'm doing? This is the catch. I'm asking you the same positive and negative values, right? Same value, 2, 2, right? So the left side area to the -2 should be equals to right side area to the 2, right? This area I gave you 0.0228. That means this area also 0.0228. Do you agree with me?
Yes.
So these two area, you know, total area is 1. Subtract to these two area, add these two area and subtract from 1 to get the leftover remaining. Total area is 1, right?
Yes. Total area is 1.
Total area 1. I'm subtracting these two guys. 0.0228 plus 0.0228. Add these two colored, then subtract from 1. You will get the remaining uncolored. That make sense?
Okay.
Okay, 9544. There are several ways to find. Now, this is the easy one. Now I am going to use the calculator to find the uncolored. Okay? So, go to the second button. Press the second button from your calculator. Then var.
So is this how we're supposed to find part B of 14?
Still, I did not come to the question. Yeah. I'm in the process of explaining the things before going to start this problem.
Okay.
You see, the problems are talking about the probabilities, right? Still, I did not come to the probability topic. Sorry for that. First, we need to get understand about the finding area, then we will move to those questions quickly, okay?
Okay.
Yeah. All right, so how do you find the area? By using the calculator. So first go to this second var, then let me check. Go to the calculator, then second button with VARS, VARS, you see there? That means basically you are going to distribution, okay? There come to the second option, normal CDF, okay? Normal CDF will give you area under the normal curve, okay? So basically you are coming to number 2. So this will give you a function, normal CDF. This is the function we are using, you know, in calculator to find what? To find the area of what? Area of any kind of normal distribution curve, maybe standard or maybe not standard, okay? Area of normal curve. But remember, now I'm giving you standard normal, right? Standard normal means what? Mean 0, standard deviation 1. Only thing is, you need to, if you want to find the area under the standard normal, simply put the two limit points of your area, left limit and right limit. In other words, the bounds, the two bounds of your area. You see now I'm asking question to find uncolored area. So two z values, right? Left bound is -2 and right bound is 2. So simply type those two numbers, left bound and right bound, under the normal CDF function. Now I'm going to type here -2, 2. That's it. Close the parentheses. So I'm showing you how to type those two. How do you type -2? You have to press the negative button, 2, then comma, again 2, then close the parentheses, then enter. Did you get that answer? 0.9544? Very close. Do you understand now how to find area by using calculator? So we use some notations for negative infinity calculator. You have to use negative E99. This is the code we use, you know, code for the calculator. If you want to type negative infinity, instead you have to type negative E99. If you want to have a positive infinity, then just type E99. Okay? I will explain this scenario by using calculator. You are given a normal CDF, sorry, standard normal curve. This is 0. I'm asking you to find, say, negative 1.48. Could you find the left side area by using calculator? You know, of course, you could find this answer by using the table, right? Right? So the table answer we got earlier, we did this problem here. For negative 1.48, we got 0.0694. But I'm going to use calculator to find this area without table. Easy. You see now, this is the area I am looking for, right? What is the bound, left bound? Of course, that area finishes here. You know the right bound of these z value, negative 1.48. But what about the left side area? This area is going forever, right? Left side. Therefore, my left side bound is negative infinity. Do you see that? This curve is going all the way up to negative infinity. Therefore, the bounds you have to type in your calculator for this left side area as negative infinity and negative 1.48. Okay, so normal CDF will give you area for that, but my left area is now negative infinity and my right bound for that area is negative 1.48. Okay, so but instead of negative infinity you have to type negative E99 from your calculator. So this is the code we use for infinity. Then type negative 1.48. This function will give you directly the left area to the 1.48 negative. Okay, let me type that and show you. I'm going to normal CDF. I'm going to normal CDF. Oh, second var. Okay, I'm moving into second normal CDF. My left bound is negative infinity. How are we going to type negative E99? This is the way. First press the negative, and where do you get E? E is where? Right over here. Shift with comma button. Second with comma will give you E. Second with comma. Then I need a 99. So this is the code for infinity. Okay. Then comma negative 1.48. Then close the parenthesis. That's it. This will give you the left area to negative 1.48. Are you getting close answer to the one we got from the table? Yes or no? So you got very close answer, right?
Yes.
Yes.
Good. That's it. Now you just listen, watch my videos and make sure that you understand first the section. Now I'm going to the problem, okay? Okay, now so far, did I talk any probability here? No, I did not talk any probability. I just explained here just finding areas. Am I right?
Right.
Yes, there's a connection between finding areas and the probability. This is the one. Okay. So the note, the probability of any z value between two values a and b could be any number. The probability of finding the z value between a and b, this is simply equals to find the area of your standard normal curve between your z values a and b. A and b could be any value, I don't know. So if you are asked to find the probability, they are simply asking you to find the area of the curve between these two values a and b. You understand? So this is the connection we have between probability of for standard normal values and the area. Okay? Simply I am telling. If you want to find the probability of z, simply find the area. Keep in mind this point. And let's move to the problem then. Okay? I need little bit space here. When I start explaining the things, I'll be messed up everything. Sorry for that. Guys, are you getting whatever I'm telling?
Yes.
Yes.
Yeah. Okay, now what is the question? Finding the probabilities. That means indirectly they are asking us to find what? Area. Okay. The first one. Find the probabilities for each using either the standard normal distribution table or calculator. That is up to you. If it is calculator, you have to write the function properly. Okay, I'm explaining the first one. Right? Remember just now I told you, if you want to find the probability of two values, it is equivalent to find the area between these two values under the standard normal curve. So I'm drawing the picture for that reason. Okay, they are talking about z here, therefore you need to draw z. If they talk about the x here, you have to write here x. Okay, but for this first test, for this coming test, I'm going to give you only for z. In procedure, in the next section, 6.2 onwards, you will find the area for any kind of normal random variable. Now we are talking only the specialized one, which is standard normal, z. Okay. Now we need to find what? The area between 0 to 0.95. 0 will be the middle point, 0 will be somewhere here. 0.95 will be positive number, will be right side of 0. Now what is my question? They are asking us indirectly finding this area, am I right? So the probability of 0 to 0.95, this is simply this area. Does that make sense? Okay, now I'm writing this, so you could find this area. Now you know how to find area by using your table or calculator. I am always using calculator because easy. Normal CDF function, I need to put the left bound, left value and the right value of your area. This is the area I'm looking for, right? Okay, tell me what are the bounds I have, left and right bounds for this area?
0,
0.
0.95.
Exactly, that's it. Now type this function, one word answer. When you write like this in your exam, make sure that you are writing this step. Don't write only answer. You need to write this normal CDF, this one. Otherwise, I don't know, right? Make sure that's okay. How do you go to normal CDF? Seconds. Var. Number 2. Normal CDF. And I need to type now 0, 0.95. That's it. Write into either 2 or 3 decimal places. I'm writing 3 decimal places. 0.329. Get the answer I gave you. Oh, yeah, I explained there by picture, right? In your answer key.
Yes.
Yes, yes, nice. I think now you should be understand this easily, right? I explained in answer key.
Yes.
Okay, very good. Now the second one, the last one, of course. So now could you draw a picture for the second problem then? Probability of two values. Literally you have to find the area. Okay. So for part 2, I'm drawing a picture again. Again, z-distributed problem. Now what are the values? That is symmetric, right? Negative 1.23 and positive 1.23. There are several ways to find this area. I'm using calculator as usual. So therefore, the probability of being two values, negative 1.23 included or without inclusion, doesn't matter, is simply, okay, what is that in terms of normal CDF? Normal CDF area two bounds, negative 1.23 comma 1.23. So if you type that, did you notice in my answer key and the one I'm writing here, is there any difference? There's a difference in my code I'm writing here, normal CDF, and the answer key I gave you. Do you see that?
Yes, sir.
Yeah, in answer key I have written two more numbers, right, inside the parentheses.
No, it was just you only added a 0. No, yeah, it was a 0 and a 1.
Do you know why it is? Could you explain what is that, the 0 and 1?
The stuff that's not shaded in.
Actually, that 0 and 1 will be mean and variance for the normal variable, but calculated default value 0, 1. That is what, even though you do not type 0, 1, it will give you the same answer. Okay. So the 0, 1 I'm including in my answer key. That means I'm including my mean and variance for the normal variable, but I explained already, you guys, the mean for the standard normal is always 0 and the variance is 1. Therefore 0, 1 is the default, 0 and 1 are default values for standard normal. Since I'm doing the problem for standard normal, you could type either 0, 1 or you could leave those two values. Okay, doesn't matter.
How do you type that in the calculator again?
You mean this normal CDF?
Yes, sir.
Go to the second button.
Okay.
Then press the var button, VARS. Do you see that?
Yes, sir.
Okay. Then after pressing go to the second option, normal CDF, you will see there.
Yeah, I see it now.
Yeah. Now you have how many days? Oh yeah, you have 2 days and to practice these things. That's it, guys. Okay, so I suggest you guys to go through first my lecture now, then come to this and practice. Okay.
Okay.
What did you get for the second problem of 14?
Which one?
Finding the area between negative 1.23 and 1.23.
Yeah,
The answer was 0.7813.
I'm showing you. Do you see that?
Can you use the same formula that you brought up earlier that didn't require the calculator?
Oh, you mean by using the table?
Yes, sir. I found the number on the table that was to the left of negative 1.23. I multiplied it by itself. Wait, do you multiply it by 2 or do you multiply it by itself? Oh, wait. Okay, I got 0.7814 with okay, I'm a little confused.
Okay, tell me first. Did you use the calculator or table?
I used the table.
Table. Okay, I will explain. Okay, because I did here by using calculator. Okay.
Yes, sir.
Okay, so I got the answer 0.7813 by using calculator. Okay,
Yes, sir.
so I'm writing somewhere here. So I got 0.7813 by using calculator. Okay, what are the values I gave you? Could you remember?
0.781.
1.23, right? I gave you
1.23.
to positive 1.23, right?
Oh,
Okay.
yes, sir. Sorry.
Now this is the area I asked you to find out, right?
Yes, sir.
Okay. If you want to use the table, what is the easiest way? Easiest way is finding the left area first. Find the left area. So
Yes,
I
sir.
believe you might have found this area.
Yes, sir.
How much you got?
1093.
0.1093, you mean?
Yes, sir.
That means this side area also should be same, right?
Yes, sir.
Okay, now subtract 1, 2 times, yes, 0.1093. Is the way you did?
Yes, sir.
Yeah, then what's the answer you got?
I got 0.7814.
Nice, only very, very small difference, right?
Yeah. If I do something like that on the test,
No
and it's
problem.
only
No problem. I'm not going to ask you multiple choice. If it is multiple choice problem, I know about this small correction by both methods, then I would have asked you to write in 2 decimal place. 2 decimal places will be same answer, am I right?
yes, sir. Yes, sir.
Yeah. Then there should be no difference. It's okay because I'm just checking your work, so I know which method you applied. Okay?
Yes, sir.
Good,
Thank you.
good. Very good, yes. Anything else, guys? I'm teaching continuously now. How many hours? Oh,
I actually only have one more question, and then I'm done.
yes. Go ahead.
Do you want us to do 6.2 and 6.3, or wait until next week after the test to do that?
You don't need to do now because I already shifted those to next. Did you check that due date of those assignments in Connect Math? I already postponed everything.
Yes, sir. For Connect Math, it's showing that they start next
Yeah,
week.
you could do the work according to the Connect Math because I'm not according to the Connect Math because I am setting my Connect Math work with our test, whatever we need to cover for the test. So always there should be an agreement with your Connect Math sections and your test portions covering.
Okay.
You see that?
Yes, sir.
Yeah, if you check your Connect Math due date, that due date should match with your sections whatever we are covering for the test. Makes sense, right?
Yes, sir.
Therefore, up to 6.4, 6.1 you need to do for this week. No worries about 6.2 and 3. That is for next week onwards. Okay?
Awesome. Thank you.
Yeah, good. Anything else?
Can you go over 5 part B again? I don't
Number
completely.
5.
Part B.
Number 5, part B. Okay, so the question is finding the probability of what? It's the same suit or different suit? Read the question carefully. Are they asking about same suit or different suit?
The cards are different suits.
Different suits. The probability question is now, actual question is finding the probability of different suits. Okay. This is the one they are asking us to find out. Am I right?
Yes, sir.
Okay. So if you denote the different suits as your event E, okay, I'm going to change this event into its complement because if I made the different suits to the complement event, the problem will be much simpler. Okay, so what is the formula we have for a complement event? the probability of any event E is simply 1 minus probability of the complement of that event. Okay? Suppose if your event E is choosing different suits, then what is your event E bar? What is the complement of different suits? Or in another word, what is the negation of this statement, different?
I'm not sure.
Okay, I'm asking you two possibilities, right? You are given some, okay. Okay, what are the two possibilities you could choose? Either different or another one is what?
The same.
Same. The opposite to different is same. The negation of different is same. Does that make sense?
I mean, so I'm also looking at the answer key you gave us, and I get like how you got it. I just don't get how you got 4
Yeah,
over
that's all.
17.
Yeah. So you got that point, right?
Yes, sir. Like
Okay.
you got the 1 subtract inside the parentheses, and then you get your answer. I just
Yes,
don't
that's
get
what I'm explaining now. So if my event E is a different suit, my event E bar is going to be same suit. Okay, that means I'm applying this formula. My original question was finding P of E. My P of E is now going to be 1 minus PE. So that means if I write the answer correctly here, the probability of E is now going to be 1 minus P of E bar. Remember, my event E is what? My event E is getting different suits, right? Getting different suits is always equals to 1 minus the probability of the same suit. Okay. Remember, your question is here. This is the one we are looking for, but that is equivalent to finding 1 minus of the probability of same suit. I am finding this guy, the probability of same suit separately. First I am finding this one, okay?
Okay.
Then after getting this answer, I am replacing that answer here and subtracting from 1. Does that make sense?
Yes, sir. I get all that. I just don't get how you got the answer.
Yes, that's the next one I am going to explain.
Okay.
The probability of same suit. Okay, remember how many cards you are drawing?
1.
One by one, 2 cards. You are drawing 2 cards, right? Okay, so what is the meaning of same suit? That means one chance you may get to both of them clubs, am I right?
Yes, sir.
Or you may get both of them, but
Kings.
say it again. No, we are talking about suits.
Oh, spade.
Spades. Or what? There are 4 suits, right?
Yeah.
Clubs, spades. You have already told you black colors. There are 2 red colors. One is hearts, right?
Yes.
Both hearts. Or both what? Diamond.
Yeah.
So first of all, make sure that you understand all 4 suits in the card pack. There are 4, right?
Yes.
Remember, you are drawing only 2 cards. I'm telling you, the probability of same suits means you will pick only one of these 4 possibilities, right? You cannot choose 2 at the same time because you are choosing only 2 cards, remember?
Yeah.
So either maybe both of them clubs, or both of them may be spades, or both of them, one of these 4 possibilities, only one is going to happen at the same time. Do you understand that?
Yes.
Yes. That means what? That means these all 4 events are mutually exclusive. That's correct?
Yes.
All 4 cannot happen at the same time. Only one of these are going to happen. Only one of these is going to happen. Is that correct?
Yes.
Yes. So I assume that what? You choose both of them hearts. I just assume, okay?
Okay.
Okay. Both of them hearts. If this is the case, tell me, how do you find the probability of both hearts? You are drawing 2 cards, right? One by one. I'm asking you, hey, what is the probability of having both hearts? That means first time when you choose hearts, how many hearts there are in heart pair? 13. Am I right?
Yes.
Out of 52. Right?
Yes.
This is the probability of getting choosing first card as a heart. Then what is the probability of second also heart? You already chosen one heart, taking outside, not replacing. Second time you will have 12.
12 over 51.
51. Right? So far I believe you understand. Is that correct?
Yes.
Okay, this is the one I have written in the answer key. If you simplify, you got 1 over 17. Is that correct? Is that correct?
Yes, sir.
Yes. Remember, I told you, I just assume that you choose to both the hearts. Or who knows? Both of them may be clubs. Am I right?
Yes.
Okay, if this is the case, do you want me to do again problem? No, I don't want to do. You will get the same probability again.
Yeah.
All four will be same probabilities. All four may be same probabilities. Do you get that point?
Yes.
That's what I multiplied by 4. Why I multiplied by 4? This is the one actually happening, right? Choosing all, two same suits, there are 4 different possibilities, right?
Yes.
Remember, we have to find now this probability. I told you earlier, these all 4 events are now mutually exclusive. Does that make sense?
Yes.
That means you have to use which formula? You have to use P, A or B formula. If 2 events are mutually exclusive, PA or B is P of A plus PB. Rule number 1. Go and check your note, okay?
Okay.
But now instead of 2 events, how many events we have?
4.
4. That means I have now A or B or C or D. Simply, this is P of A plus P of B plus P of C and plus P of D. What is my P of A here? Getting both clubs. What is my P of B? Getting both spades. What is my P of C? Getting both hearts. What is my P of D? Getting both diamonds. Remember I told you earlier, all 4 have same probability. All 4 have same probability, which is 1 over 17, right? We got already. So simply, you are adding all 1 over 17. How many 1 over 17s I have written here?
4.
4. That is why it is 4 times 1 over 17. That means what? The probability of all 4 is, that is just 4 times 1 over 17. That means what? The probability of getting same suit is nothing but 4 times 1 over 17. That makes sense now?
Yes.
Yes. So that answer now you know, 4 times 1 over 17. So subtract from 1. Now you should be good.
Yes, sir.
Yeah, more work, but I did not explain in detail because I'm going to put the same problem and same sort of problems, right?
Yes, sir.
Yeah. So I believe at least maybe 60-70% you might have understood now. Is that correct?